thinning plates, you have to kind of sort of make sure that you've not overcooked one in order that's knocking out another setting here. Obviously, this top surface is pretty boring because there's nothing to reflect up there apart from the sky really. But you can see here that it's completely reflecting that surface in the floor there. So if let's just have a mess about, put that to sort of 20, and let's put that to 50 roughness. I'll do another quick test render. We should see a bit of both going on there. So yeah, you can see it's sort of rough, and it's also reflecting. Yeah, you can see it's sort of reflecting a little bit in there as well. It's worth pointing out that if you do have some specularity / reflection going on and diffuse, you may want to then have the reflection blurring on, because effectively what you're telling the shader to be is you're saying that you're reflective to a certain degree, or you've got specularity properties, and you also have some roughness, but then the roughness isn't really sort of shown in the reflection, so you need to make sure that you have reflection blurring on for that to then look a bit more realistic. Let's just see if this is going to sort of render reasonably quickly. Well, you can see what's kind of going on. It's slightly blurred there. Obviously, that'd be more pronounced if we turn the specularity up even further. So let's just let that cook away. In fact, let me pause that for you. Yeah. Okay. There we go. You can see that effect. If I flick to the one before, you can see that the reflections are much more defined there, and there they're blurred. You can just about see them starting to go into there. Obviously, if we turn this up even further, so we say 50%, and render that again, you should see that if reflection sort of further into the object. Okay, let's finish rendering. So if we flick back to the one before, obviously it's a lot brighter because it's reflecting more light, but you can see the reflections there, and I think possibly we might have to turn down the roughness actually to see the effect of it a bit more. So let's just try that. Let's turn that down to, let's say, 15% and do another test render. Okay, it's yeah, there you go. You can see the effect much more. It's much more apparent now, in that you can, as we've turned up the reflection, turn down the roughness, also turn down the roughness. That's not blurring the reflections quite as much. You can just about see them appearing a bit more into that front surface there. Okay, but for this test, I want to turn down or turn off reflection, specularity and reflection, and let's put that back up to, let's say, 30%. The bump height is effectively, as it does in other parts of Lightwave, controls the sort of the bump amplitude of the bump. We haven't got any of that going on at the moment because we haven't got any in the, if I go into the actual sort of node flow, we haven't got any anything going into the bump mapping side of things here. I might do that later on, I don't know. But anyway, so that's pretty straightforward. That's what that controls. Now translucency. Now I've actually gone above 110% here because I wanted to really punch up this sort of checkerboard effect coming through here. But translucency tells the shader how much light is allowed to pass through into the object. Now let's just test this. If we turn this down to, let's say, I don't know, 40% and do a test render of that, we'll be able to see the effect of having that high and having that low. Let's pause it again. Okay, so that's with translucency at 40%, and if I go back to the the previous ones before the specularity was turned on. We can see the translucency when it was at 110% is the object's much brighter because the light's bouncing around on the inside. It allows us to see through the object a bit more compared to that version there. So again, it depends on what look you're after, but we want something where we can see a bit more through it, so I'm going to leave that back on 110. Now the absorption color. Now this is an interesting one. This is the one that threw me out a million times, because the way I used to think of it as absorption color was that was the color I wanted it to be on the inside. So if we sort of test render this while we're doing this. So it's a slightly blue object, and you can, I mean, the way we've got it set up at the moment is there's actually a slight green tinge to the absorption color there. Now you'd expect red until you understand how this works, because we've set it to a red color. But what we're actually getting is almost the opposite of that. And the reason for that is because the absorption color is not the color you want it to be on the inside. It's the amount that each of these values is absorbed, right? So what we're saying here is any red component of any rays entering this object are 100% absorbed, effectively, and a little bit of the green is absorbed and a little bit more of the blue is absorbed. Now we can test this, because if we say, right, okay, it's blue, and let's say we wanted this to have a red interior glow to it, well, what we want to say is that all of the red light is not absorbed, and we want all 100% of the green rays and all 100% of the blue rays to be absorbed, leaving only the red rays to be apparent. So if we test render that again, if I'm correct, it should have a red kind of glow to it, and there we go. So that was a complete revelation for me. That as soon as I figured out what was going on there, it all suddenly became a lot more easier to control, because I was setting this to be the color that I wanted it to be, and I was getting completely opposite. I was like, what the hell is going on here? I don't understand this at all. So that's the way to think about it. If you think about 0 as 0% and 255 as 100%, that whatever you set that to be is how much of that component is being absorbed, or how much of that ray, whether it's red, green or blue, is being absorbed. So that's basically the way that works. So we can see there, obviously, there when it was a slight blue, absorbing all the colours other than blue, and that one there where we're absorbing all of the colours except red. Now you can control the power of that absorption by the absorption setting here. So if we set that to 1, for example, and test render that. Let's just pause the recording again. Okay, yeah, so there we go. We can see that turning down the absorption power, if you like, or the amount that it's absorbing light rays, the effect becomes a lot less apparent. So I think it was on 30 before, and then 1. I mean, it's almost like nothing going on there, in fact. And if we crank that up to something ridiculous like 150 and do another test render and pause the camera again, yep, and there we go. So you can see that really cranking up this absorption amount, it almost in effect sort of takes over the surface color, because there's so much light being absorbed here that the absorption color is becoming much more apparent, as we can see in the various tests there. Obviously this is way too high, so let's put that down to let's say 30 again, and I'm going to leave it on the red. Actually, I quite like the red. Now the next setting is this distance. Now the distance setting is, at the moment, it's set to 3, and the reason why it's set to 3 is because I know from modeling this that bottom curve there is exactly 3 millimeters sort of thick from the bottom of the object there. If I was to turn this to, well, let's actually just turn it to 0, and you'll see the effect of that. But basically what this setting is doing, now the technical sort of description of this is it's how far from the surface sort of edge at which the light is absorbed. Now it's almost like an offset, and I'll show you why I mean that in a minute. But it almost like sort of delays the point at which absorption is taking place. I don't think that's actually technically correct, but that's